Hello, everybody. I hope you are doing well today. Um, we are now going to get into um, the water section. So, to this is week 11, I believe, and we have freshwaters, oceans, and coast to go over. And then we got week 12, which will start the non renewable energy. All right, and remember, we don't have a Um, current event this week, we have that Crazy Town podcast, and that's not due until after Thanksgiving. So you got until December 2nd, all right? Because week 13 is Thanksgiving break, all right? And then we come back for 2 more weeks, got renewable energies, and then we got cities and stuff like that. I'll put that up probably sometime this week. I'll put up week 15 and 16, all right? And finish up the things for you there. All right, I hope that's all clear. And I changed this because I think I had Thanksgiving wrong here. I did have Thanksgiving wrong, so I changed the weeks. But I think I had the homework assignments already correct on the dates there. So um, I just had the 13 and 14 mixed up. But I think I got that all set up. And if you guys see a mistake on this blackboard, please don't be afraid to tell me. All right, I have no qualms or will not get mad if someone decides to say, "Hey, Dr. Bachman, you got a mistake on Blackboard." Okay, I need all the help I can get. Believe you me. All right, so let us get into the presentation because we got a lot in this water section. We're probably going to have um, three different sections on this one, so I don't bore you with you know, long lectures here. Okay, because we're going to talk about the water importance of water's importance for peoples and ecosystems. We'll talk about the distribution of water, the difference between the fresh and marine and coastal areas and the oceans, and we'll talk about how we as humans have altered the aquatic systems. Talk about water supply problems and solutions. That's one of the biggest problems we have. A lot of people say the next wars aren't going to be over oil; they're going to be over water. Who knows? Classes of water pollution solutions. We'll talk about drinking water. We'll talk about ocean fisheries and how we're over harvesting them, how we maintain them sustainably, and also how we protect them, um, those waterways. All right. So the case study of this, and I think I've talked about this before in class, is about Louisiana losing its boot. So if you look at Louisiana now, far way back on that map there, this kind of sticks out, and this little area looks like a boot on a map. All right, and it's slowly but surely in 2020, you can see how it has totally just disappeared. All right, and it is a shame of how this has happened. And this isn't really always habitable land. This is our mangroves and stuff that stop the storm surges from coming up, right? And protecting the coast of Louisiana from getting flooded. And once these go, those waves get stronger and stronger and get further into land. Okay. The primary cause of this loss is roughly about 2,000 dams throughout the Mississippi River Basin, as well as levees have prevented the flooding that happens. So the saltwater marshes in the delta normally compact over time, but this offsets the inputs of sediment in the river. All right, so a lot of times when we have the flooding going on, all right, it fertilizes the area. So if you think about the way back when we did that first video about the Aswan Dam. The guy talked about the Aswan Dam, how it used to flood every year and was a fertile Nile crescent, right, in that area. And that's the way this used to be. But with all our dams and stuff, we're not having that flooding, and then all that stuff gets washed down to here and kills some of the sediment reaching the delta. Is killing the saltwater marshes areas. So one proposed solution is to divert the water from the rivers into the coastal wetlands inside of there. Um, and this is a good solution, I think, because we are actually talking about recreating what we used to be. All right. So the Tourist Opportunities and Revived Economies of the Gulf Coast States Act past following Deepwater Horizon spill, okay, after that big oil spill we had down there in the Gulf, create a comprehensive restoration plan, okay, to try to get the boot back on to Louisiana, per se. And we'll see how it turns out. All right, so we're doing that. We're doing this a lot in Louisiana. We're also doing this a lot in Florida. So we're trying to restore what used to be, okay, and let Mother Nature fix it. And it's going to take some time for this to actually happen, right? Mother Nature doesn't work overnight, all right, but you know, water is essential for life. Yeah, we got to remember that, right? You're what, 60% water, maybe even 80% water, something like that. Some astronomical number of you is water, right? And it's amazing how much fresh water we really don't have when we look at it. All right, because the majority of the fresh water or the water is in the oceans, 97.5% of it. So that's a lot, right? So we'll never run out of water, and water is just a couple molecules, right? So we'll never really get any more. We'll never get any less. So we'll just keep on going through that water cycle, and depending on where it is, right? So our freshwater systems is only about 2.5% of all the water. So the really drinkable water. I mean, we could drink the ocean. We could, desalinate it. But if we drank it like it is, we would not survive. Okay. But we can. We have the technology to desalinate it. We'll talk about that later. So the fresh water open to us, all right, is 2.5% of that water on the land, all right, and 79% is locked up in the ice, okay, and that's a crazy number in itself, all right. So that we have 80% that's in the ice caps. And if that 80%, we can, we can't drink it. We can go up there and go get an ice cube and bring it down and melt it, all right. But what if that melts? That adds to this ocean water. So 79% of all the fresh water is in this ice, and if that melts down, that gets to the water, and hence we get the rising tides. Okay, the groundwater, which is water that's in what I'll sometimes call it an aquifer, the water that's down underneath our ground. All right, that we sit there, we get out of a well using a well technology. All right, so 20% of the fresh water is also locked away and hard to get to, like in the ice caps. All right, and that just leaves us with about 1% of surface freshwater, water that we actually see and actually use. I mean, in the rivers and lakes and things like that. All right, 52% of that is in lakes. 38% is in the moisture of is in soil moisture, atmosphere, water within organisms, and 1% rivers. All right, so when it all boils down to it, water really is crazily distributed when it comes to forms we can't drink. Okay, the biggest one is what we can't drink. The smallest one is, in the within us and rivers and stuff that we can see. Okay, so water is a renewable and recycled resource as it passes through the water cycle. So it goes from precipitation into the rivers, out into the oceans, and then evaporates again out into the atmosphere and comes down to rain again. All right. Some of it though does get trapped underground in these aquifers. All right. Into its systems, and that's where we get this well water. All right. And we'll talk about how those are formed here in a little bit. These interactions create the web of interconnection of freshwater and marine aqua systems. So these are, a little different than the terrestrial systems, but they still have live by the laws, the limits. All right, they need to have so much sunlight, and the water needs to be a certain range and temperature and things like that. All right, for them to live, and we'll talk about that in a little bit. So what happens in one system affects the other. So even those that are far away. So the rivers are important. They distribute everything around. So everything when the rain washes down the coast into the watershed, it gets into these rivers. It carries everything all down into here. All right, and sometimes it doesn't make it either. Okay, so we have these reservoirs, and that's what really happened with that Flint. They have so a nice little damming system on their system, and they had the Flint River that ran through it, and all this stuff got caught behind. All this toxins and stuff got caught behind these reservoirs, and got into the dirt, and that's why they couldn't use the water anymore, because there was just so much sediment on the bottom, right? And polluted the water, and that's what would make the pipes uh, get release lead from them. Having said that, yeah, it can go all the way down to the river out into the sea. All right, so we actually have some nuclear waste from Fukushima washing up on our shores of uh, the Pacific, on the Pacific coast there. Okay, so surface water is located atop the Earth's surface, such as the rivers and lakes. Groundwater is the stuff beneath the surface, and there's aquifers and these little pores. Sometimes they can be like pores. Uh, Florida is basically like built on seashells, and there's a lot of holes in that rock, and that's where that water comes in, right here. And in this little area, we got more pockets of what's called well water, right, that lay down in an open cavity. Okay, any water that does not evaporate flows into the waterways and gets taken up by organisms and filtrated into the groundwater, and the groundwater can remain underground for thousands and thousands of years. All right, this is called fossil water. All right, Africa has a lot of fossil water because we can't. Sometimes those aquifers are rechargeable, and sometimes those aquifers are not rechargeable, meaning that it's there forever. They will never, we have to drill down to get to it. Okay, um, and that water is not as healthy, or since it's unreplenishable, the rain's not going to get to it. There's a little bit less time limit on that when we draw it out. So groundwater is a combination within the aquifers, porous sponge-like forms of rocks and sand. The upper border of the layer is completely filled with the water is at the water table. So here you go. The water is right in here, okay, in this little area, and this is just some rock, okay, and the water seeped down here throughout the eons, and we have what's called the occlude down here. All right, so the water can't go down any further. There's a real strong layer of rock, and there's another strong layer of rock up here too. All right, and you can see this is the recharge zone. All right, so where the water, this little wetland, rolls over here, and there's nothing stopping it from seeping in. It seeped in over the millennials and just filled this up. And then this neighbor over here who has this nice little farmland, all right, drilled down here and can get to this water. All right, and as long as this snow and rain and everything's melting down here and penetrating here and filling it up, you got a nice little system. All right, Mother Nature giving us some free water because it gets cleaned. This water gets cleaned out throughout the system, and as it trickles down in through here. All right. There's different little layers too, which is right here. We have the second layer. So here's the first occlude, and some other water got trapped up here. These ones aren't as deep, so you need more technology to get down to these bottom ones. Right, and that's what's happening a lot of times. We have a lot of competition for these smaller wells out here, and because it's cheaper, and we're drawing the water a little faster than Mother Nature can keep up with with recharging it, because the recharge zone, it's basically based on water levels of inch of rain and stuff like that. Okay, and we're drawing more out than we then gets back in there. Okay. There we go. So surface water becomes groundwater by infiltration. Groundwater becomes surface water through springs, which keeps rivers flowing and wetlands moist. So a spring would be after this occlude gets all filled up. Sometimes it will overflow. All right, so this lake might seep into here and then causes it to spring back up and keeps on filling back up into this lake. Okay, I have a little spring on my land that fills up my ponds. So right now it's raining outside. So if I go up there today, I'll see some water pouring out of that spring. So water that falls from the sky and melts in snow and glaciers that flow over the lands are called runoff. So this is what's called runoff. And they form little streams during their season of melting. All right. And it always goes down to the low-lying areas, and these are called the watershed. You just watch how water always runs downhill. right? And then it gets into the big rivers and eventually into lakes or into the oceans out there. Okay? So the area that of land drained by river systems and all the tributaries makes up the river's draining or basin watershed. So the watershed is all the area. I got a picture. All this area. Also, let me see right here. So all this area right down here is called the watershed. All right. So all the stuff that's falling down the slopes of the mountains and this little slope in here, because you see this little dry, so you know this is a little slopey area, is called the watershed. So wherever the water drains from is called the watershed. So over thousands of millions of years, and this watershed has created all the rivers and stuff we have, and they change over thousands of millions of years. They've shifted, all right, due to not only the river meandering, but the different changing of the tectonic plates and the pushing up of like the um, Grand Canyon, right? You know, that was just also a pushing of the tectonic plates as well as cutting of the Colorado River, right? So areas near the river's course that are flooded periodically within the rivers are called the floodplains. All right, we don't try to control those today, to sometimes to our detriment, because frequent flooding and deposition of soils make floodplain soil especially fertile. All right, that's how we get all that fish emulsion up in there. All right, and that is a process that Mother Nature has been doing from time and a millennial. And as soon as they started damming up that place in Egypt, they noticed that you know, without that flooding, they didn't have the Fertile Crescent anymore, right? And that happens here in our lands too. I mean, it happens in America as well. So agriculture thrives in floodplains, okay, but it can be also dangerous, okay, because we're gonna have floods when we don't want to have floods, okay. But we have what's called ripened areas along these areas, and they're forests near riversides, um, and they help prevent some of this flooding. So we want to put a ripening area. It's more of like a blockage, just like the mangroves are a blockage to some storm surges for hurricanes. These forest areas are a blockage for some of the floods. So lakes and ponds are bodies of standing surface water. Okay, the shallow in areas along the edges, and they got different zones within them. All right, so it all depends on the light penetration. Okay, the deeper it is, there's going to be less life. Okay, closer to the shore. All right, you're going to have more biodiversity and more life outside the shore. Right, and then also you're going to have the attraction of all the animals onto the shore. So ponds and lakes are can change over time as rivers and streams bring them nutrients. So there's what's called allotropic lakes and ponds, which are low in nutrients but high in oxygen. And over time, the addition of the nutrients can transition the lake or pond into an entheropic or high nutrient, low oxygen conditions. Given enough plant growth, the water body may eventually fill in completely. All right, so it could just totally disappear. So it's going to fluctuate over time. We'll go from oligopic to entheropic. Okay, and there's different kinds of these lakes and ponds, and we have also these things called wetlands. All right, and wetlands are just systems where the soil is saturated with water and containing just a shallow bit. And believe it or not, these fresh marshes and swamps and bogs are where all of our fossil fuels really come from. The majority of them were just millions of years old. All right, because this stuff never really gets to it just grows and then dies, grows and dies, grows and dies, grows and dies. It builds up in time, and as I said, it can fill up. Right, it just takes millions of years for this to fill up and then get covered up and turned into oil for us. All right. So wetlands can be seasonal, such as vernal pools that form in the snow melt. All right. So they can, there's just like, we have the wet and dry seasons in India and the jungles out there. We also have that with snow melts. Okay. Wetlands provide many water-related ecosystems services, including slowing the runoff, right? Building up, so it builds up in that little low-lying area, all right? Helping, providing an ecological service. It reduces the flooding, it recharges the aquifers, all right? And it filters pollutants because there's plants in there that want to actually get those pollutants out. And that's their ecological niche, per se. Okay, and that's what they do. Okay. Now let's get into the oceans. The oceans have the world has 5 oceans, and they're all connected, making it one single body of water, and it covers about 71% of the Earth's surface. So we have plenty of water. Even if we're not around here, we are still going to have some water. That's for sure. So ocean water contains approximately about 96% 0.5 water by mass, and the rest is ions called these salts, right? So 96% of that is water. 96.5% of that is water, but it's mixed with that salt. And we can't drink that much salt. All right, if we drink that much salt, we get in trouble. So we have to take that out before we can drink it. So the salts arise from the runoff that carries salts and the sediments and continents into the ocean. So all that years of millennials of that water running down the mountains and over the lands and back in and filling up into the oceans brought those salts there. Okay, and what didn't magically arrive. So the sunlight does not penetrate the ocean water so deeply as it does in the ponds because it has that salt in there to block them. All right, and temperatures tend to decrease within the depth, so you're going to see a lot of temperature variation. Okay, so the oceans have a ton of different currents that run through them. Okay, and it's very important that we, these are ancient trade routes, I guess you would say, and we have this one right in here. These are called gyres, and you circle around in little circles. All right, and believe it or not, there is a great big thing. Someday go and Google the Great Pacific Garbage Patch, and what's happening is here the water's circulating around, right, and picking up all this garbage and on the coast of these 2 continents and getting stuck. I think one's right here and one's right here. Okay, they're called gyres, and this is like as big as Texas. These garbage patches, right? They're huge, right? But this does a lot of different things, all right, for the atmosphere, for the climate, right? So the physical makeup of the ocean is very complex. So the surface winds and heating also create vertical currents in the seawater, and they upswell plus cold depth nutrients into the surface water. So there's not only the stuff that you see on top, there's stuff going down here in the bottom. It's called the conveyor belt, and it's bringing this cold stuff. Let me see. There's another. Let's just go right over to here. So you got the warm conveyor belt up top, and then the cold coming down here in the depths, and it's just like a big, huge stream that's going around the world, all right, driving all this stuff happening up here as well. So bringing the cold current up and the nutrients up in here to feed everybody that's falling down. So many parts of the ocean floor are rugged and complex. The underwater volcanoes can build islands above sea level. Okay, the Mid-Atlantic Ridge and underwater mountain ranges that run lengths of the Atlantic Ocean. So we actually know very little about the ocean floor. We know probably more about the moon than we do the ocean floor and what's actually in it, right? And all the different profiles that we have, okay? So the physical makeup of the ocean, the continental shelves sit below the shallow waters bordering the continent. So this is where these shelves drop off to the shelf slope break, and the continental slope angles steeply down towards the deep ocean basin. Okay, so we just talked about the thermohelial cycle, the great oceanic conveyor belt. All right, and the region of downwell in Western Europe is called Northern Deep water. So the scientists are concerned that the influx of fresh water from the melting glaciers of Greenland could disrupt this flow. So what does this mean? So we got this warm air up here, this warm current. This is just the Gulf Stream, right? The Gulf Stream, right? So they, when we were doing old trade routes, we used to catch us back over to England, right, and come back over here and catch us back, and we always get there a little bit faster because we're getting into this great jet stream. Okay, and you see all this warmth here. So this is what actually keeps Europe warm. The jet stream, the Gulf Stream. Okay, so all the westerly winds are blowing all this warm current, all this warm water air over on Europe and keeping it nice and warm. Because if you look closely on the map, Europe should be, like Canada, but it's still very, very warm. All right, it's just like Pittsburgh. Okay, and it's due to this warm air. And what's happening here, if we get all this ice up here in Greenland, it could change the salinity, the amount of salt to water ratio, all right, making it less dense. So if we add water to it, fresh water to it, it's going to turn the salt less dense, and it could slow down this conveyor belt of this being pushed down or falling down because it becomes really dense. All the fresh water gets taken out over here, all right, due to evaporation going over here and taking it away, all right, and it will stop this belt, and then this could go into another ice age. Europe can go into another ice age because it loses all this heat. So bye bye French wine. Okay. Scientists are still looking into this. They've been tracking it for a long, long time. The last 5 years, it seems to have been slowing down, but the data is not concise because it's only 5 years, and this is not something that's going to happen lickety split. Some people say it can happen in like as little as 10 years. All right, it can just shut down one day and that's it. Um, but who knows, right? We've never really been here to track it. Humanity was around one time. They say that it was around when this happened. All right, and we've got some geological evidence. The George River right here opened up, and this big lake right here, I think it was right here, opened up and flooded this area and shut this down for a while. Okay, but it came back. Um, Beyond the Mexican, the Gulf Stream, we have other things that are anomalies that happen, such as the El Nino and El Nina effect here in the ocean. So El Nino and El Nina, this is over on the east coast here of the United States. And what will happen in the El Nino southern oscillation, all right, the atmospheric pressure and the sea surface temperature, the ocean circulation in the tropic Pacific Ocean. So under normal conditions prevailing, the wind blown from the east to west along the equator, forming a large convection loop of atmosphere. So what we have here is, the normal convection loop that happens. But when we have an El Nino or an El Nina, all right, it's usually in the middle here. Okay, and this is the El Nino condition. So we have half the stuff's going this way and half the stuff's going that way. Okay, in the El Nina, what am I thinking here? So in the El Nino, in the normal conditions, usually there's a lot more heat over here in Asia. All right, and they get a lot more water, so we have drier conditions in the Pacific over here, over in the United States and in Peru and the coast of Brazil. Okay, or coast of South Africa or South America. And then another condition, in the next 7 years, it switches and we have kind of like a 50-50. The heat's more into the middle of the ocean, all right, causing a divide between the two, all right, and then the El Nino system. And this current usually happens about every 7 years, all right. So for 7 years, we'll be like this, all right, where we're getting about 50-50, all right, and then we'll get 7 years of extreme water over here and then extreme drought over here. And right now we're going through another El Nino because we have drought conditions. Okay, and this has been recorded for eons. All right, they have been doing this for a long time, and even the Peruvian Indians have this on their books, as something that they have watched over time. Okay. So marine and coastal ecosystems. So regions of ocean water differ greatly in certain zones, supporting more life than others depending on the characteristics, such as topography, temperature, salinity, nutrients, and sunlight. So these are the limiting factors for a lot of life on Earth. So in the ocean. So on land we had the biomes and the limiting factors, temperature and precipitation, and how much food's there and things like that. So it's just like that in the water. All right, the temperature and salinity would be more of the precipitation. All right, how much food's there for them to eat, how much sunlight they can get, and the topography as well as how deep is it, things like that. All right, we got all different kinds of things in a water uh, area. All right, so we got the intertidal ecosystems, which spread between the uppermost reach and high tide and low limits. So there's just when the tide comes in, there's specialized creatures that when the tide goes out, they come out like the starfish and things like that. And when the tide comes in, they're nice and hunky dory, right? And they evolved to take advantage of the switch in the tides, along with these plants and animals, and a whole different ecosystem has arrived that comes in when it's high tide and low tide. And you might notice that the snow crabs come out when it's low tide when you're walking down the beach in Florida. Okay, so tides are just periodic rising and falling. They're basically controlled by the moon, right? So the tides come in, the tides come out due to the shifting of the moon, right? And they're called the intertidal zones, are highly diverse because of the environmental conditions such as temperature, salinity, moisture change dramatically from high to low reaches. So you got to imagine, if you're going to live in this kind of climate where you're flooded all the time, you got to be able to be kind of unique in that to be able to bear that change every single day. So there's also what's called estuaries, which are bodies of water where rivers flow into the ocean, mixing salt water and fresh water. So it's like a 50-50 blend there. They're kind of, that's where everything's starting to meet. All right. And the salinity fluctuates daily due to the different tides bringing it in and taking it out. And maybe there's a flood rushing some fresh water in there or something like that. So the changes, it fluctuates. It's not one set spot. All right. So estuaries are shelters from heavy waves and oceans that provide habitat for many plants and animals, which provide food for the shellfish, birds, and fish areas. So that is a very I'm sorry about that. I don't know what's running in the background. Um, there's a lot of biodiversity in these estuary areas, okay, and a lot of birds and a lot of fish and a lot of things that eat it. It's like the coral reefs of the fresh and salt water, right? I mean, it's just abundant with life. It's amazing. So salt marshes occur when there's tides or wash over gently sloping sands and silty substrates. So water is rising and falling in these tide flows and in and out the salt marshes through the canals and tidal creeks. There's a lot of these salt marshes in Florida, right? Or even in Louisiana where they're doing, I don't know if you guys ever watched the crocodile hunter guys or alligator hunter guys on the History Channel. That's where they're actually hanging out, and they're hanging out in these salt marshes. Okay. We also have what's called the mangroves, and this was hurting the we're losing in Louisiana's boot was a bunch of these mangroves. Okay, so mangroves are trees that are salt tolerant, with roots that grow upwards and gather oxygen and other things. So, and those are also teeming with life. There's a lot of specialized fish and shellfish and snakes and other organisms that thrive among the roots in the water, while birds feed and nest in the tree foliage. So there's a lot of different levels of biodiversity just in the bottom here with the starfish, all the way up to the top with the birds. Okay. Um, We also have what's called kelp forests, and don't get as much as respect as most, but they're not as popular. I guess it's not as abundant as some of these other areas. Okay, so along many temperate coasts, so this is where you find the temperate coast with the rainforests. All right, like up there in the Pacific Northwest, where ET used to hang out. Okay, this is where you're going to find a lot of these kelp forests, and then this large brown algae called kelp, growing from the floor of the continental shelf, reaching towards the sunlight. Dense stands of underwater forests, which provide shelter for many, many fish. And this is where the sea otters and the sea urchins lived in all as well. Okay? And we also have the most popular there, probably the coral reefs, which are treasure troves of biodiversity. So this is probably one of the most popular because it's so beautiful. All right, if you ever have a chance to go do some snorkeling around a coral reef, please take that chance. It's a wonderful, wonderful experience. All right, we need to do it before we lose them all. So the coral reef is a mass of calcium carbonate composed of shells of tiny animals called corals. So these corals are living creatures. Okay? And coral reefs may be found in three areas: extension to the shoreline, a barrier island, or in a ring submerged island called an atoll. And corals are related to jellyfish, and they can capture passing food with their tentacles. They also have symbiotic relationships with the algae and the zooxanthellae, which produce food through photosynthesis. So they're very ecologically important, keystone species for habitat and all this other stuff out there for the fish and everybody to survive on. So most corals are colonial, and on the surface of the reef will contain millions of dense packed individuals. And the coral reefs host tremendous biodiversity. It's just a beautiful, beautiful setting. Okay. Many coral reefs have fallen victim to what's called coral bleaching. Okay. So here we see all the color beautiful corals here. All right, a lot of different colors, and then all of a sudden it turns into bleaching. All right, and it's whitened. All right. This occurs when the coral is stressed by increasing water temperature. So when that and elevated pollution levels as well. So when the water temperature rises, they put out the self-defense, and it gets out of control, and it just keeps on turning white. All right, and we can't really turn down the temperature of the ocean. It's kind of hard for us to do. What we need to do is mitigate what we're putting out there into the temperature of the ocean. So in the open ocean, we also have a totally different ecosystem, and we're going to just see basically phytozone or photozoic zone there. All right. So the primary productive activity occurs only on the top layer. There's not too much down there in the depths that we know about. All right. We're finding more and more because we're able to go down there in the submarine and find some things. Okay. But it's just going to be mostly microscopic life that's living out there in the middle of the oceans. All right. So when we stop there, and when we get back into the next time, we'll get into the human activities, how human activities affect the waterways. All right. So everybody have a good day, and we will get back to you soon.